Hi, this video is a demonstration of the VANTIQ real-time platform for building event-driven applications. So I'm going to start off by going through a couple of the overall concepts of VANTIQ. Here in the UI, you can see when we log into dev.vantic.com or we log into a VANTIQ instance, we're brought to the introduction page. And we can see here that there are a couple of sort of concepts that VANTIQ is organized around. So we've got sources. Sources are how we interact or interface to the external world. We can attach to, sources where we remotely gather query information. So we might get information from a weather source. We might use it to update a CRM system like Salesforce. We might use it to bring data into the platform through mechanisms like MQTT or AMQP. We can also bring data into the platform via REST and WebSockets. Types are how we store data persistently. So if we decide we want to keep something, if we take in a stream of data and we want to hold on to it for a little while, we store it in a type. And a type looks an awful lot like a table inside of a database. But types are a lot more flexible. So, for example, here you see I have a type called responder, and you can see I've identified some various properties. I can do things like identify natural keys and indexes on things and so forth. Rules are how we tie logic to events inside of the system, and rules are really interesting. The way that rules work is when you create a rule always starts with something called a when clause. So you can say when, and then you're saying when a particular event occurs. So when an insert occurs. So this would be used for, whenever somebody inserts something into one of those persistent storage, one of the types, or an update or a delete occurs on one of those. When a message arrives from a source, like when a message arrives from our chatbot source or something of that nature. Or we could also do when a publish occurs and then on an internal topic. And the thing to keep in mind is that the entire platform is asynchronous and built on a reactive model. And so everything that happens in the system, including audits, any change to memory inside of the system, any change to a type, to a source, any message published anywhere, all of those things can be triggered by this when clause. So the next thing is, of course, procedures. Procedures are how we can basically write specific functions so that if we have a piece of logic that we do over and over and we want to use it inside of a rule or execute it separately, we can put together a procedure. And both rules and procedures are written in the VANTIQ DSL, a domain-specific language, but that's really, really easy to learn because it looks like and it feels like JavaScript and SQL, and you'll see a lot of examples of that as we go through. Analytic models, we allow you to import analytic models in the PFA, the Predictive Format Analytics, and this is really useful because if you've got some predictive algorithms that you've created in PFA, then you can simply import them into the platform and let them drive, a scoring engine or drive various behaviors inside of the platform. And I'll talk about nodes and configurations a little bit later. Nodes are how we identify other VANTIQ instances in which that we can participate and share information between in a completely federated and distributed architecture. And configurations are how we collect various VANTIQ artifacts, all the sources, the types, the rules, all these different things, and how we can manage them as a collection so that we can push them to other nodes in a distributed environment. So one thing to keep in mind is that this demonstration is something that VANTIQ is capable of doing, but not per se what VANTIQ does. You can use VANTIQ to build any kind of event-driven platform. This demonstration focuses on a healthcare application, and in our healthcare application, we're going to do a couple of things. One is we're going to take a look at the status of our various devices. So we've got a handful of devices that are constantly emitting an update of their status. You can think of these like IoT devices. So they're emitting things like voltage, so we know the device status, whether the device is functioning or not, and also whether or not the battery is in good shape, because this is a patient wearable. We'll also be monitoring our patient. We've got a handful of patients and we're showing their, their heart rate as well as their steps per minute. And so these are elderly patients, so we don't expect them to be lifting weights. So if their heart rate goes too high or too low, that potentially could indicate something is problematic for that given patient. But of course, the first thing that we've got to do is make sure that the devices are functioning. So I want to walk you through how it was built. The first thing is I'm going to show you a description of the battery readings. And so here you can see that every 5 seconds or so, we have a stream of events that comes into the system and is showing us things like the device's ID, its location on the planet in GeoJSON format, as well as the voltage of the battery itself. And what we're going to do is we're going to use that battery voltage, pass it into a predictive model that determines whether or not that battery is going to fail at some point in time, determine whether or not it requires maintenance of some form. There's also a reading from the patients themselves. So the device on a separate topic emits a handful of readings. And so again, every 5 seconds or so, we'll see the patient's information, their mobile phone number, their device ID, probably a masked version of their name that's probably not their real name, as well as some username information, their location on the planet as well, which should map up with the device itself, as well as their steps per minute and their heart rate. So these are some of the attributes that we'll be monitoring and determining based on various situations whether or not those are problematic. So the first thing that we're going to take a look at here is the application that is responsible for monitoring the battery and ensuring that the battery is in good working order. And here you see I've toggled over to our Project Explorer, and we see a project resource graph. This shows us the elements, those objects that are inside of VANTIQ that are made up of this particular project, specifically monitoring the battery. We also see a handwritten rule called unpublished device battery. And then we also see a collaboration. And one of the things that's really unique about VANTIQ is the ability not only to identify a situation of interest, but also to act upon that situation of interest. Because just identifying a situation is really just dashboarding. But the power behind an event-driven system is the ability to not only enrich data, but then to be able to act upon it. And in this first scenario, what we see is we've got an internal topic that I showed you a moment ago called device battery, where we're getting the voltage and various information from the battery, encountering a rule that invokes an analytical model. We'll take a look at that in just a moment, as well as writing into or reading from a device and then opening up what's called the collaboration. And this blue and green diagram on the right is the collaboration. So let's walk through each part of this and see what's actually going on. The first thing that happens is that message comes in on the battery topic and encounters the rule unpublished device battery. Most of this file is just comments, so we'll just telling you what the various parts of it does. So this is really only about 4 or 5 lines long. And the first part says, when a publish occurs on device battery, and I'm just going to call it, and I'll retarget the I'll target a variable named device data. So when a publish occurs on device battery, take that JSON object and put it into device data. Then the next thing that happens is I take the device data's voltage, the voltage that came in from the battery, and I put it into an object called info, because this is what I'm going to pass to my predictive model. The next thing that occurs here is that basically we create a variable called the prediction, and we pass it to a predictive model called battery, and we pass in that info object, which has the battery's voltage. And then finally, we add to the JSON object the prediction, and then we upsert, which is an insert or an update to the device type, our persistent storage. We upsert all the information so that we keep the last record of it. And that pretty much handles taking the information, determining if the battery is in normal mode or maintenance mode, and that's all this rule really does. And of course, it writes it into the storage. Everything else happens now inside this collaboration. And what this collaboration does is it starts with an initiate activity. And the initiate activity basically says, for sensors or the device themselves, when an update occurs on the device, if the device status is either critical or maintenance, basically if it's not operating normally, that opens up a collaboration. And the idea behind a collaboration is it's the ability to act on the enrichment or the correlation in the aggregation of the data streams that we find. So we've opened up a collaboration when that occurs. The next thing we do is we encounter a recommendation activity, and all these blue all these blue boxes are what we call activities. And an activity or a primitive is commonly used functionality that you'd use over and over and over wrapped up neatly so that you don't have to write any code. So here we have an activity called find text. There's a recommendation activity. And what we're doing with the recommendation activity is I'm saying go out and I want to find a responder. I want to find individuals in the responder type. I want a max number of recommendations, which is going to be 2. So I'm saying I want 2 recommendations. And then I want to use a built-in procedure called R's nearby recommendations. And so what that does is it uses the location of my sensor to match against the location of my responders to recommend me the 2 closest responders. So I'm able to very quickly, without writing any code, identify the 2 closest responders. Once it finds those responders, it then goes out and notifies those responders. It notifies the technicians. And it does so by using a mobile collaboration. So here we have a body maintenance request for the device and then the device's ID. We have a title and then we have this payload object. And what this payload object is it's the creation of a form for all the information that we want to send down to the device. So what we can do is we can simply drag on these elements. Like if I wanted, a drop list on this, I can simply drag it onto the form. If I wanted to create an inline button, I drag it onto the form and so forth. So I drag these items onto the form. And then of course we use this form input as the driver for this payload. So we basically paste that form into here. It's all done automatically for us. And then once we do that, then we go ahead and we wait for one of those responders to submit with the mobile application a response, whether or not they accept or reject it. And if they accept it, if it's, you see there on the screen, it says, if event values.accepted equals true, then we'll go ahead and we'll assign the technician. Once the technician is assigned, then we'll do 2 things. We're going to track their location on the planet, and whenever the technician is updated, we'll update their location on the map, and when they arrive, we'll send them a text message to let them know they've actually arrived on the scene. At the same time, we'll send the official repair notification, which has supplemental information about what to do. It's another one of those mobile forms, and in addition to the repair notification, it has some things like scanning barcodes that we've asked for. And then finally, when they submit it, it will close out the collaboration. Okay, so now that we've done that, let's go ahead and take a look at this all in practice. You've pretty much seen all of the code necessary to build this part of the application. Let's see it in practice. So I'll come back over here to the home screen or the device view, and I'm going to simulate a drop in voltage on one of the devices. Now remember, when the voltage, each time a voltage reading comes into the platform, the platform then pushes the voltage through a predictive model. The predictive model then determines whether or not it's going to fail. So in this particular case, the voltage is dropped to a point where it thinks it's going to require maintenance in a short period of time. It's also identified a location on the map where that actually exists. And it's also identified a replace battery collaboration. These are just essentially visualizations that pull information out of the various types to display them on the screen. But again, no code was written to develop any of these particular attributes of the system. All right, so the next thing that you probably saw is that a notification has actually gone down to the mobile device. And you see that we actually have a service request. So I'll open up the service request. And so I click on the service request. And you see, of course, that it matches the form that we created in the RCS editor. So I'm going to now accept this service request. And when I hit submit, the next part of the collaboration occurs, which is that it goes out, sends that message back to the platform recognizes the acceptance, and then once it gets the acceptance, it then sends back to the mobile device the form for triaging this particular issue. So I open up the battery repair form and I click scan barcode. And now I just go ahead and scan the barcode because it's one of the input forms that it's asked me. It's also something about showing documentation. So if I was the repair technician and I wanted to see how to replace the battery, I can do things like that. The other thing that you'll notice is that I've gotten an arrival notice because I've arrived at my location. And then finally what I'll do is I'll go ahead and I'll choose that the device is repaired. Now before I repair the device, of course, I need to return the battery to normal. So I need to take out the old battery, put the new battery in, and then once the new battery signal starts passing through the predictive model, we'll see that it will move back from maintenance back to normal mode, that the new battery is functioning properly. And then finally, what we can do on the mobile device is we can go ahead and say that the device is repaired, and we can submit it. And then once we go ahead and submit that, then we see that the collaboration closes, and in this case, it disappears off the screen. So you've seen the entire application end to end, and that entire flow of sending the mobile forms down to the user, all of those various activities, all contained within this small rule and this collaborative activity. All right, so the next part of the system that I want to show you is what if we wanted to then take that information and push it down to a regional location. Imagine if we have these home healthcare centers or hospitals or whatever it might be, and they don't have or they can't afford to push all of the data back up to a cloud. Each one needs to operate autonomously from the other, but each one needs to have the ability to have all the latest versions of the rules. VANTIQ is not only a distributed system, but it's a dynamic system where we can take an entire project and push it down to a location. And the way that we do that in VANTIQ is we define a couple of things. One is we define something called nodes. So if we go over here to nodes, you'll see I have two defined, Acme Edge 1 and Acme Edge 2. We define a username and a URI at which to get to those. Those could be part of the same system in another namespace. They could be completely separate systems halfway across the world or anywhere. And you could have tens of them or tens of thousands of them. You can truly create distributed environments of any architectural configuration, partial mesh, full mesh, hierarchical tree, whatever's appropriate. Okay, so once you've defined your nodes, the next thing that you can do, and you'll notice that I've also given them a property, edge type is regional. The next thing you can do is you can define what's called a configuration. And in a configuration, what you do is you define all the pieces of your application. So first you provide a constraint which says, I want to send this down to all the regional nodes. Then you define all of the different resources that you want to send down, like the analytical model, the collaboration for the heart rate and the replace battery, the various procedures that you want, the rules, the sources, the types, all of the things that make up your application. And then once you've defined your configuration, and you can even put configurations, and they'll automatically pass each of the configurations down to the appropriate level. Then you go ahead and you publish. You deploy those configurations, and you can deploy them to a running real-time system in which any changes that you've made, any updates that you've made will deploy out to that system. And then once the system deployment is complete, the system shows you a summary. And then on the summary page, you can see all the deployment activity, and it will render you up a graph that shows the relationship between the various nodes and objects on the system. And it's really easy to do distributed programming inside of VANTIQ because it gives you the opportunity to create these sort of abstract notions. For example, if I wanted, if this rule was running down at the edge and I wanted it to run back up at the top, process by the edge, I can simply add this process by statement onto it. So process by name is Acme Healthcare. If I wanted to run a distributed query, so for example, if I went to procedures here, and let's say I wanted to run a federated query across all of those nodes, well, then what I could do is I could create a new procedure, and I'll say, get all. And I'm just going to do select from, and I'll say select from patient, and then we'll say processed by, and we'll put in the constraint for who I want to process it by. So we want to process it by all regional nodes, and we'll just do that for now. So if I now run my get all procedure, you can see it reaches out across each of those environments and brings them back to me. So these are all users that you haven't even seen because all these users are down at the edge. So there's a distributed query, and it even tells you where they came from. So here you see this one came from Acme Edge 1. This was from Acme Edge 1. And this one down here, this is from Acme Edge 2. Acme Edge 2. So you can see different users from across a distributed and federated environment. So I hope this gives you at least a first look at the VANTIQ platform for building event-driven applications. And thanks for watching.